assuming things go well, we'll 10x that output next year. So we'll aim to do maybe 50 to 100,000 humanoid robots next year.
Elon Musk stated. But to turn that massive number into reality, Tesla can't rely on a one-size-fits-all design for every environment. A robot that cleans floors cannot be the same as one working on a factory line or patrolling a construction site. So what must Tesla adjust to ensure Optimus truly fits each specific environment? Before we begin, please help us reach 9,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. What makes each working environment require a different robot design? Tesla Bot will not achieve optimal performance if only a single design is used for all environments, whether at home, in factories, or outdoors. The nature of work in each environment demands completely different materials, structures, and load-bearing capacities. In factories, robots must perform tasks like lifting 44 to 66 pounds components, operating continuously for 8 to 12 hours per day, traversing concrete floors, and withstanding impacts on assembly lines. This requires Tesla to use a chassis made of 7000 series aluminum alloy or stainless steel, with tensile strength above 72,500 pounds per square inch. In addition, the joints must deliver a torque of at least 44 to 59 foot-pounds in the shoulders and legs, and the outer shell must resist oil contamination and high temperatures. By contrast, in home environments, tasks are much lighter: folding laundry, opening doors, carrying a glass of water, or assisting the elderly to stand up. For these tasks, using lightweight materials like PA66 or ABS engineering plastics combined with composites helps reduce the robot's weight below 88 pounds, while also minimizing the risk of injury upon contact. If Tesla does not differentiate configurations between environments and uses the same design for all purposes, the robot may be overbuilt for simple tasks or underpowered for heavy ones, leading to lower efficiency, higher energy use, and increased risk of damage. Working environments also strongly affect the drivetrain and battery system. Actuators are the most power-hungry components in humanoid robots. In factories, robots require BLDC servo motors with 0.4 to 0.67 horsepower per joint to perform forceful, precise movements. At home, robots can rely on smaller motors rated at 0.1 to 0.16 horsepower, enough for gentle manipulation and agile motion in tight spaces. Using overly powerful motors for light tasks reduces electrical efficiency and unnecessarily increases battery capacity, weight, and cost. For example, factory robots need batteries of 1.6 to 2.0 kilowatt-hours to operate 8 hours under heavy load, while home-use robots only need about 0.8 to 1.1 kilowatt-hours. Not only hardware but sensors and control software must also adapt to the intended environment. In factories, robots require long-range LiDAR, 130 to 200 feet, to avoid machines, as well as high-precision force sensors in the hands with plus or minus 0.22 pounds, sensitivity to handle heavy objects. Meanwhile, home robots only need short-range proximity sensors, standard RGB cameras, and microphones for voice command recognition. Factory navigation focuses on device alignment and repeating action cycles with high accuracy, whereas home robots must analyze user behavior, avoid pets, and detect children. When a robot is designed specifically for its environment, production costs can be greatly optimized. Eliminating unnecessary modules reduces weight, simplifies the structure, and increases reliability. Assuming each functional module accounts for 5% of the total cost, removing 4 to 6 modules could reduce manufacturing costs by 20 to 30%. Given Tesla's target price of $15,000 to $20,000 per unit, this strategy could bring the cost down to around $12,000 or less, making large-scale commercialization viable. Simpler designs also make robots easier to repair, less prone to mechanical failure, and easier to maintain. All these factors show that developing specialized versions like Optimus Home, Optimus Factory, and Optimus Outdoor is essential for the successful global rollout of Tesla Bot. This is not merely a product strategy, but a technical necessity to ensure operational performance, safety, and cost efficiency. While versions can still share common software, FSD chips, and Grok AI systems, the mechanical design, actuators, and sensors must be tailored to specific usage environments to ensure that each robot performs reliably and economically. Additionally, categorizing Tesla Bot by use case opens the door for a modular production strategy, where core components can be flexibly assembled depending on the robot's purpose. For instance, the same central body and AI system could serve both home and outdoor versions, while the arms, sensors, and drivetrains would differ. With this approach, Tesla could replicate its success with the Model 3 and Model Y platform, where over 70% of components are shared, reducing cost and boosting manufacturing speed. This modular design fits well into Tesla's automated production lines at Giga, Texas, allowing version customization by swapping a few key components during final assembly. This could be the key for Tesla to scale up production rapidly while maintaining tight control over quality and cost, especially critical if Elon Musk intends to manufacture millions of Optimus units each year as stated. Once again, please help us reach 9,500 subscribers. This is important for us to stay motivated. Thank you. How does specialized Optimus Gen 3 design help reduce costs? As Tesla sets its sights on producing millions of Optimus robots annually, cost is no longer a secondary factor. It becomes the key determinant of commercial viability. With the projected price of humanoid robots ranging from $15,000 to $20,000, any savings in manufacturing, configuration, or maintenance could translate into billions of dollars when scaled. Designing a single all-purpose version for every environment would force Tesla to include the most powerful components in a single unit, resulting in excess hardware, unnecessary weight, and overbuilt systems for each user segment. In contrast, dividing the product line into specialized variants, Optimus Home, Optimus Factory, and Optimus Outdoor, can significantly reduce costs across 3 levels: hardware, mass production, and operational maintenance. Starting with hardware costs, an all-purpose robot would need to combine industrial-grade structural frames for factory use, infrared and GPS modules for outdoor use, and sophisticated AI communication systems and fine actuators for domestic use. As a result, component costs could increase by 30 to 50% compared to optimized configurations. Assuming each unnecessary module contributes around 5% of total production cost, eliminating 4 to 6 modules could cut costs by 20 to 30%. For example, an Optimus Home would not require a high-load frame or active cool-in system. Just these 2 modules alone could save $1,500 to $2,000 per unit. Similarly, the Optimus Outdoor version would not need advanced NLP or soft finger actuators designed for home environments, further eliminating 5 to 8% in avoidable costs. In terms of mass production costs, specialized variants simplify the assembly line. Each robot type only requires predefined modules without the need to test every redundant system. Given that a single robot may go through 600 to 800 assembly steps and 20% of those steps are specific to a particular environment, separating variants could reduce assembly time from 3 to 4 hours per unit to 2 to 3 hours. This shortens workloads for production robots and technicians alike. Not only does this reduce labor costs, but it also lowers the inventory of spare components, one of the biggest hidden costs in large-scale manufacturing. Based on Tesla's Gigafactory model, a single minute of downtime due to misconfigured parts can cost tens of thousands of dollars. Therefore, minimizing complexity per version directly improves operational efficiency. When it comes to maintenance and repair costs, specialized robots are easier to diagnose and service. An Optimus Home unit can be optimized with only 12 to 14 key modules, compared to 18 to 20 in a multi-purpose robot, making repairs simpler and requiring less technician training. Furthermore, components are not overused or misapplied, so they last longer. For instance, factory-grade actuators are designed for high power, but if installed in a home-use robot, they remain underutilized, leading to wasted energy and lower overall efficiency. In contrast, lightweight actuators designed for Optimus Home can last twice as long when used at appropriate loads. From a logistics and operation standpoint, managing a uniform ecosystem of robots tailored for different purposes enables easier selection for customers and easier deployment for businesses. Suppose a company uses 100 Optimus factory units and a household uses one Optimus home. If both versions shared the same structure, diagnosing a failure would take twice as long due to unrelated variables. Specialized designs allow the diagnostic software to focus precisely, reducing repair time from 5 hours to 2 hours, and cutting operating costs by 20 to 40% depending on deployment scale. Ultimately, product cost is not just about purchase price, it's also about practical utility. A $15,000 robot that completes 90% of its design tasks will always be more economical than an $18,000 robot that performs poorly due to improper configuration. Environment-specific optimization increases return on investment per dollar spent, which is especially important as Tesla moves toward hourly or monthly leasing of Tesla bots. An optimized Optimus home could cost users less than $2 per hour, compared to $3 to $4 per hour if a general-purpose robot were used instead. In conclusion, dividing Tesla bot into specialized variants is not only a smart design strategy, but the only viable way to control lifecycle costs, from development and manufacturing to operation and maintenance. As Tesla aims to deliver robots to both enterprises and households on a multi-million unit scale, specialization is the most practical path to lowering prices, improving efficiency, reducing failure rates, and accelerating the adoption of humanoid robots worldwide. What does Tesla need to do to produce and deploy millions of Optimus robots globally, efficiently? As Tesla sets its goal of producing millions of Optimus units annually, the challenge is not just about building a product, but about scaling deployment, accelerating global expansion, and ensuring synchronized operations worldwide. If Tesla tries to use a single robot model for all purposes, it would not only create a technical burden, but also cause bottlenecks in manufacturing, distribution, training, and maintenance at scale. On the other hand, by dividing Optimus into product lines like Optimus Home, Factory, and Outdoor, Tesla can build dedicated production lines, optimized for specific configurations, enabling faster production and a more controlled, phased market rollout. From a manufacturing perspective, each specialized version allows for a simpler and more stable assembly line. For example, if Optimus Home only requires 12 core modules, instead of the 20 found in a general-purpose unit, the production line becomes shorter, requires fewer inspection steps, and faces lower assembly error risks. Assuming each module requires 10 minutes for quality inspection, eliminating 6 to 8 modules could reduce average production time per robot from 4 hours to under 3 hours. This is particularly critical for Tesla, a company already experienced in high-speed automated EV manufacturing at its gigafactories. When applied to robots, a similar model will be even more effective if products are standardized by version. Moreover, breaking the product into versions allows Tesla to allocate production resources more efficiently across its global factories. For instance, Optimus Home, compact and consumer-oriented, can be produced at Giga Mexico or Giga Berlin, closer to key consumer markets in Europe and Latin America. Meanwhile, Optimus Factory can be produced mainly at Giga Texas, where Tesla is already trialing the robot internally on automotive production lines. This minimizes the need for long-distance shipping, saving logistics costs, and shortening the time from production to delivery. A bulky, over-integrated, all-purpose product would force centralized production in just a few locations, causing supply bottlenecks when demand spikes. Beyond manufacturing, AI training and software updates can also be accelerated when products are divided by usage purpose. With each Optimus version assigned a clear task set, industrial operation, household support, or outdoor mobility. Training data can be grouped, narrowed in scope, and optimized faster. For example, the Optimus Home Group only needs to focus on indoor environments like kitchens, living rooms, or bathrooms, allowing AI to quickly learn common situations and improve interaction accuracy. In contrast, a multi-purpose robot that must simultaneously learn from outdoor videos, industrial sites, and home settings would process more slowly, consume more dojo resources, and fragment the training algorithms. Segmented product development is the most effective way to train AI models quickly, efficiently, and with focus. From a commercial rollout standpoint, environment-optimized variants allow Tesla to distribute robots in phases across specific regional markets, instead of releasing a one-size-fits-all product that would require heavy customization to meet local demands. A pressing question looms over Tesla's Optimus Gen 3. Can Tesla reduce the robot's price sufficiently to transform it into a mass-market consumer product? Elon Musk's recent statements suggest not only that this is achievable, but that it's central to Tesla's strategy for commercializing Optimus. By leveraging a redesigned architecture, optimized materials, and Tesla's unparalleled production scale, Optimus Gen 3 could redefine affordability in humanoid robotics, potentially hitting a price point that competitors can only dream of. So, how much can the price of Tesla Optimus Gen 3 drop with the all-new design? Before we begin, please help us reach 11,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Optimus and the latest news. Elon Musk has repeatedly stressed that Optimus must be priced below the cost of human labor in developed economies to achieve widespread adoption. In a 2024 shareholder meeting, Musk projected that, with sufficient optimization, production costs for Optimus could fall below $20,000. This figure is striking when compared to existing robotic platforms, such as Boston Dynamics Spot, which retails for approximately $74,500, or Figure AI's Figure 01, estimated at $100,000 to $150,000 for early prototypes. Achieving such a low price requires a revolutionary approach to design, eliminating inefficiencies while maintaining safety and functionality. The Optimus Gen 3 design represents a significant leap forward in efficiency. According to leaks and footage from Tesla's 2025 Investor Day, the robot is approximately 22 pounds lighter than its Gen 2 predecessor and incorporates 30% fewer mechanical components. This reduction simplifies assembly, lowers maintenance costs, and minimizes expenses related to quality control and inventory management, key drivers of mass production costs. Industry analysts estimate that streamlining a robot's mechanical structure can reduce assembly time by up to 25%, translating to significant savings according to the Robotics Manufacturing Report in 2025. Material choices further enhance cost efficiency. Tesla has reportedly transitioned from traditional aluminum and steel to advanced cast alloys and reinforced polymers for select external components. These materials, which are lighter and cheaper, can be produced at scale using molding or additive manufacturing techniques like 3D printing. A 2025 study by McKinsey on robotic production suggests that consolidating a robot's shell from dozens of parts to 4 to 5 major pieces could slash material and machining costs by 40 to 50%. For Optimus, this shift could reduce the cost of the exoskeleton by over $2,000 per unit at scale. A cornerstone of Tesla's cost reduction strategy is its reuse of existing automotive hardware and software. The full self-driving chip, which powers Optimus's AI capabilities, is the same one used in Tesla's vehicles, with over 1.2 million units produced annually in 2024 by Tesla Q 4 2024 production report. By avoiding the need to develop a bespoke processor, Tesla saves an estimated $50 to $100 million in R&D costs. Similarly, cameras, sensors, and electric motors are sourced from Tesla's automotive supply chain, which benefits from economies of scale unmatched in the robotics industry. For instance, Tesla's ability to procure high-resolution cameras at $50 per unit, compared to $200 for competitors, significantly lowers Optimus's bill of materials. Internal estimates from Tesla's production team suggest that at a production volume of 500,000 units per year, the manufacturing cost of Optimus Gen 3 could range between $14,000 and $16,000 per unit. This is already competitive with the base price of a Tesla Model 3, which retailed for $39,990 in 2025. If Tesla offers financing or bundles Optimus with subscription-based AI services, the effective retail price could dip below Musk's $20,000 target, making it accessible to a broader consumer base. Tesla's pricing strategy extends beyond hardware costs, leveraging innovative business models to maximize affordability. Unlike traditional robotics companies that rely on high-margin hardware sales, Tesla could adopt a low-margin approach similar to its Model 3 and Solar Roof strategies. By selling Optimus near cost, Tesla could generate long-term revenue through software, updates, AI-powered subscriptions, or service contracts. For example, an Optimus as a service model could allow consumers to rent the robot for $50 to $100 per month for tasks like elder care, home maintenance, or meal preparation, mirroring trends in the service robotics market, which is projected to grow to $103.3 billion by 2030. This approach aligns with Tesla's target market: households, particularly those with elderly members, special care needs, or professionals seeking AI-driven assistance. While industrial robots can justify price tags of $50,000 or more, consumer robots require affordability akin to smartphones or laptops. A 2025 survey by Deloitte found that 62% of U.S. consumers would consider purchasing a home assistant robot priced under $20,000, especially if offered with flexible financing. Tesla's ability to offer monthly payment plans could make Optimus as accessible as a $500 smartphone spread over 2 years. Tesla's vertical integration provides a structural advantage over competitors. Unlike Boston Dynamics, which excels in technology but lacks large-scale manufacturing, or Figure AI, which depends on third-party suppliers, Tesla controls its entire production pipeline, from chips and software to factories. This allows Tesla to optimize costs at every stage. For instance, Agility Robotics Digit, deployed in Amazon warehouses, carries a price tag of $40,000 to $50,000 due to high U.S. production costs. In contrast, Tesla's Gigafactories, which produced over 410,000 vehicles in Q2 2025, provide the infrastructure to manufacture Optimus at an unprecedented scale. Tesla's Fremont factory is being retooled for Optimus pilot production, with plans to have several thousand units operational by the end of 2025. This scalability is critical, as economies of scale drive down costs. Historical data from Tesla's Model Y production shows that each doubling of output reduces unit costs by 15 to 20%. If Tesla achieves Musk's vision of producing 1 million Optimus units annually by 2030, unit costs could plummet to $10,000 to $12,000, a price point that would disrupt the robotics industry. How have operating and charging times improved after this big update? Among the most common inquiries about Tesla's Optimus is its operational endurance and recharge requirements, critical factors for potential buyers evaluating its practicality as a home or workplace assistant. As outsiders to Tesla's development team, pinpointing exact technical specifications, such as battery performance or mechanical details, poses a challenge. Tesla claims Optimus can operate for up to 20 hours daily with a 2.3 kilowatt-hour battery, a figure that sparks skepticism given the energy demands of humanoid robots. Let's dive deeper to assess the feasibility of this claim and explore how Optimus's task-learning capabilities could make it a transformative companion. Tesla's assertion that Optimus can function for 20 hours daily is ambitious, particularly with a modest 2.3 kilowatt-hour battery, comparable to that of a high-end electric bicycle. For context, Boston Dynamics Atlas, a leading humanoid robot, operates for approximately 4 to 6 hours on a 3.5 kilowatt-hour battery under intensive conditions. Human workers typically manage 8-hour shifts with breaks for meals and rest, whereas robots like Optimus may only require brief recharges. Assuming a continuous runtime of 6 hours per charge, based on energy consumption rates of similar robots like Agility Robotics Digit, which uses 2.5 kilowatt-hours for 5 to 7 hours, Optimus would need 3 30-minute recharge cycles to approach the 20-hour mark. This recharge model aligns with Tesla's use of high-efficiency lithium-ion cells, similar to those in its Model 3, which support rapid charging at up to 50 kilowatts. A 2025 study by McKinsey estimates that modern humanoid robots can achieve 80% charge in 20 to 30 minutes with advanced battery management systems. For household users, such brief pauses are unlikely to disrupt daily routines, as most won't require Optimus to operate continuously for 20 hours. Instead, its design prioritizes flexibility for shorter, task-specific sessions, distinguishing it from industrial robots built for relentless factory work. What sets Optimus apart is its ability to learn tasks from instructional videos, a feature that could make it an intuitive daily companion without requiring extensive user training. Equipped with 8 2D cameras on its head and powered by Tesla's full self-driving chip, Optimus leverages deep learning algorithms to interpret and replicate tasks. This mirrors Tesla's approach to autonomous driving, where neural networks process visual data to navigate complex environments. A 2025 report by Gartner highlights that vision-based learning in robots can reduce training time by 60% compared to traditional programming methods. Imagine a scenario where Optimus watches a cooking tutorial via its cameras and then prepares a meal autonomously, from chopping vegetables to cleaning the kitchen. This capability, demonstrated in Tesla's 2025 We Robot event, where Optimus replicated a recipe after a single video, could revolutionize household assistance. Similarly, for cleaning tasks, users could play a tutorial, and Optimus would mop floors or organize spaces while the owner relaxes. A 2025 Deloitte survey found that 68% of U.S. consumers value robots that simplify household chores, with 55% willing to pay a premium for autonomous learning features. The success of these tasks hinges on Optimus's dexterous hands, which account for approximately 80% of task precision, according to Tesla's internal engineering estimates. Modeled after human hands with 5 fingers of varying lengths, the latest iteration boasts 22 degrees of freedom, surpassing the 11 degrees of freedom of its predecessor and outpacing competitors like Figure AY's Figure 01 with 15 degrees of freedom. This advancement enables delicate operations such as handling an egg, manipulating battery cells, or watering plants, as showcased in Tesla's 2025 demo videos. Elon Musk has claimed that Optimus's hand can perform complex tasks like playing the piano or threading a needle, feats that typically require years of human practice. A 2025 study by IEEE confirms that hands with over 20 degrees of freedom can achieve 95% of human dexterity levels, supporting Musk's assertions. However, the increased complexity raises production costs, with each hand estimated at $5,000 to $7,000, or 30% of Optimus's total manufacturing cost. While Optimus's video learning capability is groundbreaking, it raises concerns about exposure to unsafe or malicious content. If Optimus can learn from any video, mechanisms to filter inappropriate instructions are essential. Tesla has not publicly detailed its content moderation strategy, but a 2025 UNESCO report emphasizes the need for AI systems to include robust safety protocols to prevent misuse. Additionally, the EU's AI Act, effective February 2025, mandates transparency in AI training data, which could complicate Tesla's deployment timeline. On the positive side, video-based learning accelerates Tesla's ability to refine Optimus's capabilities. By integrating Grok Voice AI, Optimus can also respond to verbal instructions, enhancing its accessibility for non-tech-savvy users.
So we got the first starships on Mars, gather critical data. So the first flights there we'll send with the Optimus robot. So we can go out there and explore and kind of prepare the way for humans. And that'll be a very cool image if we're able to achieve it by launching end of next year. It would actually technically arrive in 2027.
Elon Musk announced that Tesla Optimus Gen 3 has completed its initial trial production phase. Each software update brings new capabilities. In a live video on X, Elon officially revealed the new timeline for the Tesla bot's journey to Mars and the range of tasks, from simple to complex, that Optimus can perform in its early days of deployment. How will this ambitious vision become a reality? But before we begin, please help us reach 8,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Optimus and the latest news. Elon Musk shared that SpaceX will send a Starship carrying the Tesla Optimus robot to Mars by the end of 2026, with a landing expected in 2027. The mission's goal goes beyond exploration. It aims to prepare for human presence on the Red Planet. According to Musk, Optimus will gather vital data, explore the terrain, and even help build infrastructure such as habitats, water recycling systems, and energy production stations. This vision may sound like something out of a science fiction movie, but if successful, the image of Optimus walking on the Martian surface will surely become a historic moment. But is this really feasible? Let's break it down. Tesla Optimus is designed to handle dangerous and repetitive tasks, making it an ideal candidate for the harsh environment of Mars. Standing at 5.6 feet tall, weighing 125 pounds, and capable of lifting up to 40 pounds, Optimus can move at a speed of 4.9 miles per hour and is powered by advanced AI derived from Tesla's self-driving technology. These capabilities enable the robot to perform tasks such as transporting equipment, assembling structures, and even operating machinery in zero-gravity conditions and extreme temperatures. However, this ambition is far from easy. Although Starship is the most powerful vehicle ever built, it has yet to successfully land on Mars. Landing on the Red Planet's thin atmosphere presents a major technical challenge, requiring extreme precision. Moreover, Starship's testing history has seen multiple failures, from explosions in early prototypes to persistent engine issues. Experts like Chris Impey from the University of Arizona have expressed skepticism, calling the end of 2026 goal unrealistic due to time and resource constraints. The cost of such a mission is also a significant barrier, with estimates reaching into the trillions of dollars to build a self-sustaining settlement on Mars. So, is this plan a reality? As of now, it remains part of Elon Musk's long-term vision, a man known for setting bold and ambitious goals. Musk has shared plans to send 1,000 to 2,000 starships every 2 years to establish a settlement on Mars. While technically possible, the timeline and resources remain major uncertainties. However, if SpaceX can overcome these challenges, Optimus could become a pioneer in preparing Mars for human arrival, ushering in a new era of space exploration. How will the latest updates make Tesla Optimus useful? Now let's shift to what's happening with Tesla Optimus right here on Earth. At the end of May 2025, Tesla announced significant advancements in the development of its humanoid robot, with the latest updates showing that Optimus is getting closer to becoming a reality. According to the Q1 2025 earnings call, Tesla is preparing its Fremont factory to launch a pilot production line for Optimus, with the goal of completing it by the end of the year. The ambitious plan is to deploy thousands of Optimus units across Tesla's North American factories before 2025 concludes, marking a major transition from research and development to real-world application. The latest videos from Tesla reveal that Optimus Gen 3 has made remarkable improvements compared to the first version. The robot now walks more smoothly, performs complex dance moves, some of which many of us couldn't pull off, and even handles factory tasks like sorting blocks, using tools, transporting components, and disposing of waste in a lab setting. These capabilities are powered by advanced neural networks and machine learning simulations, optimized from Tesla's self-driving technology. Musk also revealed that Optimus will be equipped with the AI-4 chip, with plans to upgrade to AI-5 next year, enabling the robot to interact more effectively with its surroundings. Still, not everything is going smoothly. Some of Optimus's tasks still rely on remote control, known as teleoperation, indicating that the robot is not yet fully autonomous, as envisioned. Additionally, Tesla faces a major challenge due to export restrictions on rare earth metals from China, which directly impacts its production capabilities. Robotics experts, including those who have compared Optimus to Boston Dynamics robots, argue that Tesla's humanoid robot still lags behind leading competitors in terms of automation and agility. Nevertheless, Musk remains unfazed. He predicts that Optimus will become the biggest product in Tesla's history, with a production goal of 5,000 to 10,000 units by 2025 and tens of millions annually in the future. The projected price? Around $20,000 for the base model, and up to $30,000 for a more advanced version. These advancements suggest that Tesla is on the right track, but the journey of Optimus is still filled with challenges. From optimizing the production line to overcoming material supply barriers, Tesla must prove that Optimus is not just a bold concept, but a practical solution for both Earth and Mars. In addition to the major updates on Tesla Optimus, Elon Musk recently revealed a key operational detail regarding the Mars exploration plan. In Musk's bold vision of transforming humanity into a multi-planetary species, an interplanetary communication network is a core element, ensuring connectivity between Earth, Mars, and future space colonies. SpaceX, through its Starlink project, is leading the effort to develop this system, referred to as MarsLink. With the ambition of providing broadband internet between planets, MarsLink promises to support space missions, from robotic operations like Tesla Optimus to the construction of settlements on Mars. This article will analyze how this interplanetary network functions, based on the latest information about its technology, challenges, and potential. The MarsLink system operates on the principle of expanding the Starlink model, a satellite network that has revolutionized internet access on Earth, with over 7,000 satellites in low Earth orbit. To connect Earth and Mars, SpaceX plans to deploy a cluster of satellites around Mars, forming a local network similar to Starlink. These satellites will ensure communication across the Martian surface, supporting devices such as robots, research stations, and spacecraft. More importantly, they will connect to Earth through an interplanetary relay system, using advanced laser link technology to transmit data across hundreds of millions of kilometers. According to Elon's proposal at the Mars Exploration Program Analysis Group meeting, MarsLink could provide a minimum bandwidth of 4 megabits per second, enough to transmit high-resolution images, scientific data, and text messages, though it would not support real-time communication. The core technology behind MarsLink is laser communication, a major advancement over traditional radio waves. Lasers allow for higher data transmission speeds, less interference, and are more suitable for interplanetary distances. On Earth, Starlink satellites already use laser links to communicate with one another, forming an efficient mesh network. Similarly, on Mars, MarsLink satellites will communicate both among themselves and with Starlink satellites in Earth's orbit via laser beams, ensuring a continuous data stream. When Earth and Mars are on opposite sides of the Sun, a phenomenon known as solar conjunction, signals can be disrupted. To address this, SpaceX may deploy relay satellites at strategic locations, such as Lagrange points, where gravitational forces are balanced, allowing satellites to maintain position with minimal fuel. These relay satellites would receive and forward data, ensuring uninterrupted connectivity even when the distance between the two planets ranges from 21 million to 249 million miles. An unavoidable feature of interplanetary networks is signal latency. Due to the speed of light being a fundamental limit, it takes between 3 to 22 minutes for a signal to travel from Earth to Mars, depending on the relative positions of the two planets. This results in a round-trip delay of 6 to 44 minutes, making real-time applications such as video calls or online gaming impossible. Instead, MarsLink is optimized for tasks that do not require immediate response, such as sending emails, transmitting scientific data, or streaming video content. In addition to data transmission, MarsLink also holds great potential for scientific and navigational applications. In 2024, NASA provided $200,000 to $300,000 in funding to SpaceX to study the integration of MarsLink into future Mars sample return missions, highlighting its value in relaying data from robots or spacecraft back to Earth. Moreover, The system could offer a GPS-like service for Mars, helping robots like Tesla Optimus and future astronauts navigate the Martian surface, monitor weather conditions, and predict dust storms. These capabilities not only support scientific exploration, but also lay the groundwork for a self-sustaining colony, where stable communication among settlers and with Earth will be essential. More than just a plan for the distant future, what potential does Tesla Optimus bring to humans right now? The Tesla Optimus Gen 3 is not just a machine. It is a dedicated caregiver and a reliable companion, bringing hospital-level care directly to your home. Powered by Grok 3's advanced AI, it can monitor health, adjust treatments in real time, and ensure that loved ones remain safe and independent, even without a nurse present. Currently, the unrevealed prototype of the Tesla Optimus Gen 3 marks Tesla's most advanced version, designed for real-world applications such as nursing. It reflects years of breakthroughs in robotics and AI integration, built for precision and adaptability, making it the perfect assistant for caregiving tasks. Designed with upgraded actuators delivering 30 Newton-meters of torque per joint, the Tesla Optimus Gen 3 achieves a walking speed of 0.8 meters per second, an improvement of 33% over Gen 2. Its dexterity reaches new heights with hands featuring 22 degrees of freedom, powered by micro-actuators that provide 1,550 Newton-meters of gripping force, ideal for delicate tasks such as administering injections or adjusting medical equipment. The robot is capable of moving within hospital-like environments, thanks to its 360-degree range of motion at the torso. Optimus Gen 3's advanced sensor suite includes 12 high-resolution cameras and 8 ultrasonic sensors in the head, providing real-time environmental awareness with a latency of just 0.1 seconds, critical for obstacle avoidance and meeting healthcare demands. Its adaptability is driven by a neural network capable of processing 100 trillion calculations per second, paired with Grok 3 AI, enabling the robot to learn tasks on the fly. Additionally, Optimus Gen 3 boasts impressive safety features, with a collision avoidance accuracy of 99.9%. Of course, there will be some blind spots that even Optimus cannot detect, just like certain sensations that humans are also unable to perceive. Its limb joints are limited to 50 newtons to prevent injuries, and its emergency stop latency is optimized to ensure safe interactions with patients, even in chaotic environments. We believe this will be the greatest product ever created, as every one of the 8 billion people on Earth will likely want their own Optimus companion, or even two. This could lead to the production of over 10 billion units in the future. And it won't stop at Gen 3. Optimus models will continue to evolve and improve until we reach Gen X. Elon Musk has set an ambitious goal for 2026 to begin low-volume production of 5,000 to 10,000 units for internal use at Tesla facilities. These units will be tested for nursing capabilities and environmental control. Each unit is expected to cost between $20,000 and $25,000 to produce, utilizing Tesla's Gigafactory infrastructure. By the end of 2026, scalability will increase, with plans to ramp up production to 50,000 to 100,000 units per year, aiming for deployment in hospitals and healthcare facilities. Additionally, Tesla has emphasized that components originally developed for its electric vehicles are being repurposed and integrated into the Optimus robot, significantly accelerating production beyond conventional timelines. This means Tesla doesn't have to start from scratch or design an entirely new set of components for Optimus. At the same time, the company dramatically reduces its reliance on external suppliers. Thanks to this advantage, Musk is confident in his goal of producing thousands of robots by 2025, with an impressively low production cost of just $10,000 per unit. The presence of robots like Optimus could influence how people perceive and behave in their daily lives. Some individuals may find it exciting and beneficial to have a robot that can handle household chores and assist with work, as demonstrated by Optimus's capabilities. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you. Please give a thumbs up if you like this. Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe and have fun.